Good morning, class. This is Module 1, covering chapters 1, 2, 3. And here's Chapter 1, Introduction to Statistics. All right. So, Chapter 1, Introduction to Statistics. True or false? The value of variance and standard deviation is never negative. It's a true statement. These are absolute quantities that is a measure of variation of all values from the mean. It can be zero. So here's the proof. In essence, looking at the formulas, again, remember you have access to the formula sheet. For the population variance, sigma squared, and we use Greek letters for population. Sigma squared is summation of x minus mu quantity squared over capital N, and the population standard deviation, you take a root of that. If you look at this expression, the top, x minus mu, whether it's positive or negative makes no difference. When you square it, becomes positive. Summation of positive numbers is positive, divided by n, which is a positive number. This is positive, so it's square root. The formula for the sample variance is summation of x minus x bar, similar to that, but we divide by n minus 1. And we use lowercase n versus capital N, which represents the population. We use sigma squared. For the sample, we use S squared. We use mu for population mean. We use X bar for sample mean, and you can also use this formula. And sample standard deviation is the same thing. You take a root. So that's the justification as to why it's non-negative. What kind of variable weights of bear is quantitative or qualitative? It's quantitative variable. Weights of bears gives numbers that represent counts or measurements. What kind of variable gender of bears is quantitative or qualitative? It's qualitative. Gender of bears is distinguished by non-numeric characteristics. Now, anybody wants to read this paragraph for us? Quantitative and qualitative variables are two types of variables usually used in data analysis and statistics. Quantitative variables, also known as numerical variables, represent measurement or quantities that can be expressed numerically. Qualitative variables, also known as categorical variables, represent characteristics or qualities that do not have a numerical value. These variables are typically divided into categories or groups. Examples of qualitative variables include gender, marital status, or types of cars. In summary, quantitative variables involve numerical measurements or quantities, while qualitative variables represent non-numerical characteristics or categories. One thing that I want to add here, class, there are numbers such as zip codes, social security numbers that are considered qualitative. I can't emphasize this enough because they just represent groups, categories. define population and sample in statistics. Population is the complete collection of all elements, scores, people, measurements, etc., to be studied. Sample, a sub-collection, portion, or fraction of elements drawn from a population. Population. The population refers to the entire set of individuals, objects, or events that possess certain characteristics of interest and are the subject of statistical investigation. However, populations can be large and sometimes impossible to study in their entirety due to practical limitations. Sample. A sample is a subset or a smaller representative group selected from the population. It is a portion of the population that is chosen to represent the whole. In summary, the population refers to the entire group of interest, while a sample is a smaller subset selected from the population for analysis. Statistical analyses are typically conducted on samples to draw conclusions about the population from which they were drawn. In short, class, population means all. You have to be able to read and see whether it gives you the entire group or a fraction, a portion of that. Generally speaking, we use a sample to make a decision about the population. The value of the middle term in a ranked data set is called the median. So if we rank them from smallest to largest, the one in the middle is called the median. Given any data, how do you find the mode? Mode is the value that appears with the greatest frequency among the data. A data set can have a one, more than one, or no mode. No mode happens when all numbers appear with equal frequency. True or false? The number of chairs is considered to be a continuous variable. That's a false statement. The number of chairs is not continuous. We cannot have 1/4 of a chair as an example. Discrete data result when the number of possible values is either a finite number or a countable number of possible values, 0, 1, 2, 3. Examples: number of students in a class, number of cars in a parking lot. Continuous data can take any value in an interval. Data result from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruption, or jumps. Examples: the weight or height of a person. One thing I want to add, we can't have 1/4 of a chair, but or we can't have 2.5 cars, but we could say every household on the average has 1.5 cars. That can be said. What is a Pareto chart? What does each axis represent? A Pareto chart, named after Vilfredo Pareto, is a bar graph for categorical or qualitative data. Similar to histogram for quantitative data, which is used to summarize discrete or continuous data that are measured on an interval scale. The vertical axis represents frequencies or relative frequencies. And horizontal scale represents different categories. Bars are arranged, this is important, in descending order to emphasize the order of impact. Define a parameter and a statistic. Parameter, a numerical measurement describing some characteristic of a population. Statistic, a numerical measurement describing some characteristic of a sample. Define random sample and simple random sample. Random sample. Members of the population are selected in such a way that each individual member has an equal chance of being selected. Simple random sample of size n subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen. In other words, random sample deals with an individual, one subject. So every subject has an equal chance of being selected. Whereas simple random sampling, every sample of the same size will have the same chance. Define the following types of sampling: systematic, convenience, stratified, and cluster. Systematic sampling. Select some starting point and then select every kth element in population. Example, in a population of 50,000 people, a statistician selects every 100th person for sampling. You have to have a starting point randomly, of course. Convenient sampling. Use results that are easy to get. Example, standing at a mall or grocery store and asking people to answer questions would be an example of a convenience sample. Stratified sampling. Divide the population into homogeneous. The subjects within the same subgroup must be similar and share the same characteristics. Subgroups called strata, and then obtaining a simple random sample from each subgroup or strata. Cluster sampling. Divide the population into sections or clusters, non-homogeneous subgroups. Then randomly select some of those clusters and choose all the members from those selected clusters. To understand this, in the case of a stratified sampling, the groups are practically the same. So from each group, randomly we select some. Whereas in the case of a cluster sampling, every group seems to be similar. And then you randomly select one or a few groups. A simple example of that in a class, if we are interested in selecting a sample of class with different grades, if you put all the A's and B's and C's in different categories and pick a few from each one, that is stratified, because the A group and the B group and the C group within the group, they are homogeneous. But if you have a group that contains A, B, C, so forth and so forth, and the next one and the next one, and you randomly select one of those groups or some of those groups, that becomes cluster sample. Number 12, what are different levels of measurement of data? Give examples. Nominal level of measurement is described by data that consist of names, labels, or categories only, and the data can't be arranged in some order, such as low to high. Just a qualitative or a nominal that we, or categorical that we have explained already. Example, survey responses of yes, no, and undecided. Eye colors, blue, brown, black, other. Political party, Democrat, Republican, independent, other. Ordinal level of measurement. Ordinal level of measurement involves data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. Examples, rank of colleges. Rank can be first, second, third, and so on, which determines an ordering. Assigning grades of A, B, C, D, or F. These grades can be arranged in order, but we can determine the difference between the grades. We want to continue with the same question, whether different levels of measurements, and here's the next one, interval. Interval level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. A value of zero does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. Examples, body temperature of 98.2 degrees Fahrenheit and 98.6 degrees Fahrenheit, years 1000, 2000, 1776, 1492, and so on. Ratio level. Ratio level of measurement data can be arranged in order. Differences can be found and are meaningful, and there is a natural zero starting point where zero indicates that none of the quantity is present. Differences and ratios are both meaningful. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Here's the examples. Distances traveled. 0 kilometers represents no distance traveled, and 400 kilometers is twice as far as 200 kilometers. Prices of books. $0 does represent no cost, and $100 book does cost twice as much as a $50 book. What's the difference between an observational study and an experiment? Give examples. Observational study. Observing and measuring specific characteristics without attempting to modify or influence the individuals being studied. In an observational study, the researcher merely observes and tries to draw a conclusion based on the observation. Here's an example. A study took a random sample of adults, asking them about their bedtime habits. The data showed that people who drank a glass of warm milk before bedtime were more likely to go to sleep earlier than those who didn't. Experiment. Apply some treatment and then observe its effect on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. In other words, an experiment is a controlled study that aims to determine the effect of one or more independent, also known as explanatory variable or factors, on a dependent, which is also known as outcome or response variable. Any independent variable and tries, now there is, okay, any combination of the values. I lost that one more time. Any combination of the values of the factors is called a treatment. The researcher manipulates the independent variable and tries to determine how the manipulation influences the dependent variable in an experimental study. Here's an example. Another study took a group of adults and randomly divided them into two groups. One group was told to drink warm milk every night for a week, while the other group was told not to drink warm milk that week. Researchers then compared when each group fell asleep. Observational study versus an experiment. Describe cross-sectional, retrospective, and prospective studies. Give examples. Okay, one more time. Anybody feels like reading for us? All right. Cross-sectional study. Data are observed. It's an observational study. Measured and collected at one point in time. A cross-sectional study is like a snapshot of a particular group of people. At a given point in time, it is used to describe what's happening at that time. Example, a medical study examining the frequency of cancer among a population of different geographical locations. By doing this, any differences among them can most likely be attributed to geographical locations differences rather than something that happened over time. Retrospective or case control study. Data are collected from the past. By going back in time, data that already exist. In other words, example, researchers ask participants about their smoking habits over the past 20 years. Then they can analyze any possible correlation between their smoking habits and diseases, diseases such as lung cancer. I'm going to continue with the same question. The next one is prospective or longitudinal or cohort study. Data are collected in the future from groups called cohorts, sharing common factors. Longitudinal studies look at a group of people over an extended period. Example, a medical study follows a cohort of middle-aged people who vary in terms of smoking habits to test the hypothesis that the 20-year incidence rate of lung cancer will be highest among heavy smokers, followed by moderate smokers, and then non-smokers. Example, the Framingham Heart Study began in 1948 and is a long-term ongoing cardiovascular cohort study of residents of the city of Framingham, Massachusetts. What is sampling error, non-sampling error, and non-random sampling error? Sampling error. Sampling error is the difference between a sample result and the true population result that is the consequence of chance sample variation. So it's a simple case. In a sample, you have a smaller group, and there might be some differences due to chance as a result of the size. Non-sampling error. The non-sampling error occurs due to data that are incorrectly collected, recorded, or analyzed. It may happen by selecting a biased sample, using a defective instrument, or copying the data incorrectly. Somehow, some kind of an error on the behalf of the group that are in charge of this study. Non-random sampling error. Non-random sampling error is the result of using a sampling method that is not random, such as using a convenient sample or a voluntary response sample. And what is voluntary response sample or self-selected survey? One in which the respondents themselves decide whether to be included. In this case, valid conclusion can be made only about the specific group of people who agree to participate. That's the nature of most surveys. What are some characteristics of an experiment? Confounding. Confounding occurs in an experiment when the experimenter is not able to distinguish between the effect of different factors. Common confounders are characteristics of the participants such as body mass index, smoking status, age at onset of illness, socioeconomic status, educational status, extent of support network, and life events. For example, we are looking at the exposure to alcohol use, which results in lung cancer. In that case, the confounder, for example, would be smoking, because smoking does have an effect on that. So it's hard to tell which one has caused that. That's the concept of confounding. Blinding. Subject does not know he or she is receiving a treatment or placebo. Placebo is, as you most likely know, it's like sugar pill. So the subject is under the assumption that is receiving the treatment. Blocks, groups of subjects with similar characteristics. So many times you want to find the effect of a treatment on various types of people, so you cut them into different blocks. Let's continue with the question. What are some characteristics of an experiment? Completely randomized experimental design means subjects are put into blocks through a process of random selection. Replication. Repetition of an experiment when there are enough subjects to recognize the differences in different treatments. So if you are checking something, the size of a sample is important, and of course there are always limitations to time and money, and we may not have enough of those to have a large sample, but the larger the sample, normally the better the result. Replication. Sample size refers to the number of individuals or items selected from a population to be included in a sample for a research study or statistical analysis. It must be large enough to display the true nature of the population data and should be obtained using an appropriate random method. And randomness is the key. Explain some misuses of statistics. Statistics can be misused a lot, and here's some of it. Bad samples, small samples, misleading graphs. This is used a lot. Distorted percentages, loaded questions, order of questions, refusals, because they don't want to answer, correlation and causality, because correlation doesn't necessarily mean causation, self-interest study, precise numbers, all short pictures. Normally, if they report with precise numbers, that's not correct. So, for example, pictographs. Double the length, width, and height of a cube, and the volume increases by a factor of 8 because 2 cubed is 8. To correctly interpret a graph, we should analyze the numerical information given in the graph instead of being misled by its general shape. So if you look at this one, for example, each side is 10. If you change the side to 20, it's not doubling the volume, it's multiplying by 8, right? So double the side and it becomes 8 times larger, the volume. Deliberate distortion, loaded question. Should the governor have the line item veto to eliminate waste versus should the governor have the line item veto or not? This one is a loaded question. 95% said yes. Obviously, we don't want any waste. In this case, only 53% said yes. Note, if sample data are not collected in an appropriate way, the data may be completely useless, that no amount of statistical training can salvage them. Randomness typically plays a critical role in determining which data to collect. A research center questioned 2,000 adults in the US to estimate the proportion of the population favoring death penalty for murderers. It was found that 70% are in favor of death penalty for murderers. State the individual, variable, population, sample, parameter, and statistics. So we're going to answer those, and it's a good idea to start with the population first. So a research center questioned 2,000 adults in the US. So that means all adults would be the population. So what about those 2,000? That would be the sample that is being used. The sample is the 2,000 adults in the US survey. What about an individual? One of those adults. So one adult in the US. One of those adults. Variable. You are in favor or you're against it. So favoring death penalty for murderers, that would be the one that is changing, is the variable. Statistics. As you read the question, it was found that 70% are in favor. 70% of what? Those 2,000. So that's statistic. The 70% in favor of death penalty for murderers in this study, those 70%. So this would be the proportion. That is the statistics. Parameter is not given. It's unknown. I want you to know that. Because we don't have access to the portion of the entire population that are in favor. So it is unknown. In some texts, they may use the same 70% in favor of death penalty for murderers in the US. But again, here's the statistics. This is not the parameter. In some texts, they might. I just want you to know that, which is incorrect, by the way. Decide if each of the following describes an observational study or an experiment. A, the height of shoppers at the mall was recorded. We are not doing anything, we're just recording, we are just observing. So that's an observational study. A drug is given to a group of people and the reaction observed, we are controlling and therefore we are experimenting. It's an experiment. A group of students are told to listen to music while taking a test, and the results are compared to a group not listening to music. Definitely, it's an experiment. Because we are comparing two groups. One is given the treatment, meaning listen to the music, and one is not. The temperature on randomly selected days throughout the year were measured. We are just observing the temperature. That's all. The gender of children born in January were tallied. Again, we are not doing anything. We are just observing, observational study. The growth rate of bacteria is compared before and after adding alcohol. Definitely, it's an experiment. We are checking to see what is the effect of alcohol on growth rate of bacteria. It's an experiment.